Hello, everyone. I'd like to welcome you to the first episode of our new podcast, AI in the Real World. Today, we've got a really exciting conversation between Taleb Alashkar and Ramesh Raskar. I'm going to intro both of them. We'll get a little feel for who they are, and then we're going to let them kind of dive into the world of AI. So first, we're going to start with Taleb. Taleb, how are you today?
Doing great. Thank you, Jeffrey.
Excellent, excellent. So Taleb, why don't you tell us a little bit about yourself, and then I can kind of dive in and poke around if we need to poke around a little bit more.
Thank you, Jeffrey. I'm CTO and co-founder of AlgoFace. I have PhD in computer vision machine learning from France back between 2011 and 2015. Then I moved to US early 2016 to work in face soft biometrics, augmented reality for a human face. After that, I worked for a company for like driver monitoring system here in Michigan, where I moved from Boston. And since 2017, working on AlgoFace, which was incubated inside mother company Algo, and we spun off last March. In AlgoFace, like we focus on an inclusive, unbiased AI solution for a human face.
Awesome. Thank you very much. That's going to be make for a great conversation here today. Ramesh, I'm going to toss it over to you. Same question. Give us a little intro about yourself. Tell us some accomplishments and why we're interested in hearing from you today.
Thank you, Jeffrey. Wonderful to be here. I'm Ramesh. I'm a professor at MIT, and a lot of my work is at the intersection of computer vision, machine learning, imaging, and digital health. I think we live in an amazing era where improvements in computing are impacting not only other digital systems, but also many physical systems. So my excitement is really at the intersection of the digital and physical systems.
Awesome. So this is definitely going to be a great conversation. Ramesh, I see you have a bunch of awards in here. I'm looking at your LinkedIn. I advise everybody who's listening to check out both Taleb and Ramesh's LinkedIn. Tons of great accomplishments, tons of great, experiences that they've had. But, Ramesh, you've got a ton of awards here that I'm looking at. Is there any one of these that really jump out that we want to talk about?
I mean, the awards that I'm really proud of are the work done by my students, my postdocs, and my colleagues. And, it's unfair that the award has my name on it, but it's really, a recognition of all the hard work, all the talent that I get to work with on a daily basis. So awards like the Lemelson Award that recognizes accomplishments in engineering, or my ACM SIGGRAPH Award, which recognizes accomplishments in visual computing, are just make me very proud given my team here.
Awesome. Yeah, that definitely shows, obviously, your guidance and your tutelage certainly moves these things along, which is going to be fantastic. So I want to kind of dive into our conversation here, and really, I'm going to take a back seat. I want these two brilliant minds to kind of have a conversation about where AI is, where they see it going, and some of the cool technologies that are going into AI today. So I'm gonna turn it over to you guys and let you guys kind of go at it. And certainly, I'm here if we need be.
Yeah, I can start. Thank you, Jeffrey. And Taleb, let's talk about the current state of AI and some unspoken challenges. And as we look at the tremendous progress in the ability to exploit compute and data and new algorithms in AI, it's become very obvious that as far as the compute and algorithms are concerned, there's a tremendous progress, but data continues to remain one of the bottlenecks. And one mechanism around that is to simply harness the data that's either crowdsourced or tap into sources that remain siloed. And to do that, there are 2 or 3 problems we need to solve. One is, first of all, we have to figure out if the data is reasonable quality. And so some kind of a data janitorial work is very critical. The second is that a lot of this data is actually very sensitive. It could be health data or identifiable data, financial data, and it's important to gather that in a way that preserves privacy and overcomes bias and other important values. And the third is that the data itself is illiquid. and to make it liquid, we need to create new incentive mechanisms so that folks will actually start sharing. So far, I would say in the Web 2.0 world, the incentive has mainly been, some other tentative benefits, whether it's social media or, traffic directions and so on. But as time goes on, we need a completely different economy to make the data more liquid and lubricate the whole ecosystem. So I see that there's three main challenges in dealing with data. So Taleb, I know you're excited about many aspects of compute, algorithms, as well as data. What do you see as the current bottlenecks and unspoken challenges?
Yeah, when it comes to data, like that's true, like AI becomes really in our lives recently. It's departed from research labs into our lives like around 10 years ago for two reasons, like computational power of GPUs plus availability of a huge amount of data, especially like deep learning based supervised machine learning solutions, which are the common AI now. Like maybe more than 90% of any AI solution in action is deep learning based supervised based learning approach. But now, like when we figure out like there's a lot of data, when you want to build real world AI solutions you want to put it in the hand of millions, sometimes billions of people, you can figure out like data is a huge challenge I don't want to repeat the same reasons that you mentioned. They are illiquid. They may use privacy information, medical data, or biometrics data that we are dealing with in AlgoFace, or the data themselves are not representative enough. Like there's always different data. You acquire data from different machines, from different sensors. They have different characteristics. Or like in medical data or many scenarios, there's certain classes or certain areas you have a lot of data, and there's corner or edge cases that you have very, very little of data. That's a very, very big challenge, time consuming and resource consuming ahead of any AI or machine learning based project. Now we believe, thanks to the advancement in two areas, the one is GAN, generative adversarial networks, and rendering simulator, we reached the stage in last couple of years where synthetic data is realistic enough to incorporate and add these synthetic data and harness our real-world data together and train machine learning model. Synthetic data generation is very, very hot topic and is very important. It can save tons of time in front of machine learning models into production. It can give us more robust AI solution because we have more diverse and more inclusive data set. If we can really produce extremely realistic synthetic data in short amount of time.
So that's fascinating, right, Taleb? I mean, the ability to create new synthetic data, and it kind of reminds me of the trends in genetic cloning, the Dolly the sheep. And the concern always is, yes, it's okay to create Dolly the sheep, but it's difficult to create something entirely synthetic. And so right now in the world of synthetic data, we always need some data before we can create more synthetic data. So let's go back to the beginning of synthetic data, right? I mean, there are certain benefits to creating synthetic data. First of all, it can be created in large quantities without worrying about tapping into real world data. Once you have some real world data as a genesis, synthetic data can be simulated in many ways. So kind of compute can generate data, which is always fascinating. It has benefits that when you do release the synthetic data, you don't have to worry about issues like privacy, because if you do it right, synthetic data may not reveal any identifiable data in the original data. And probably the most important is that in synthetic data, you can play with parameters that matter for training machine learning algorithms, like bias and sample size, and so on. So we feel that the world of synthetic data has emerged very quickly over the last few years, as you said, because of some of the new opportunities in generative models. But tell us a little bit more about how you see this challenge of starting with at least some real data, and what is the potential for going to truly purely synthetic data?
Yeah. That's very true. Like, it is maybe like catch-22 problem in the world of data. I need some data, real data, to generate synthetic data. If our ultimate goal is to kill the need of real data, currently that's not possible. It is not something viable right now. But the advantage is now using some technique of generative models plus transfer learning. Sometimes you need really tiny amount of data to generate tons of data. So let's assume I need to train certain algorithm, I need like 1 million images or 1 million scan or whatever. You can really get this 1 million out of maybe a few thousands if you have the same pre-trained model or the right transfer learning techniques. The dilemma here starts like the synthetic data is still inheriting certain characteristic or statistical distribution of the real data. And we need to be careful, especially when it comes to privacy. Like, if we want to discuss privacy, some overrepresented classes or objects inside the real data that we are using to generate synthetic data, this information can be leaked to the to the synthetic data as well. We need to be very careful about that. We should not use that blindly. And there's some technique to overcome that technically by using some differential privacy technique or federated learning. Maybe Ramesh, you can also comment on these two techniques, and it's still emerging field. There's no final solution, but I still see it very valuable, and using differential privacy and federated learning can reduce and mitigate this risk to high level.
That's absolutely true. I think some of the challenges you mentioned with synthetic data, such as need for some original data before you can run a generative model on it, and second, from an algorithmic point of view, the need for really good transfer learning algorithms, because what you train on synthetic data may not generalize to the distribution of the real data that you actually care about are real. And the benefit of synthetic data that you could reduce leakage and achieve some kind of a privacy or even a trade secret of your original data is very critical. I mean, I would say techniques like differential privacy or federated learning, or what we do in our group at MIT, which is called split learning, which is a variation of federated learning. So techniques like split learning and others can definitely play a very critical role in maintaining privacy. But don't you think they are somewhat orthogonal to synthetic data? Because the whole idea behind creating synthetic data is that the data itself is, extremely high quality in its raw form. So if you use differential privacy and add some noise to it, you kind of reducing the value of the synthetic data. And if you use federated learning or split learning like techniques, which are more suitable for distributed computing, then you run into this problem that you need some coordination between client and server. Don't you think the benefit of synthetic data is something you can just put it out there, and you can either buy it or sell it or produce it yourself, and it's almost like a JPEG file that anybody can decompress after the fact?
Yeah, that's true. Like those techniques that help you to find the leakage of sensitive information from real data to sensitive data at the same time may reduce the quality or the value of sensitive data. But I believe if we keep pushing in this direction from both industry and academia, we will find some sweet spot between privacy and protecting the real world data privacy, plus having high quality of sensitive data. And sensitive data also, it is not only about privacy. Like, yeah, privacy is very important topic now in the age of AI, how we can have high accurate AI based solution without strip the privacy of everybody on the earth. But sensitive data generation has many other values of, for example, corner cases and edge cases in many scenarios. Like you cannot find, for example, think about some skin condition analysis using AI, okay, or some skin dermatology. There's some common disease. You can find tons of images for those problems or disease, but there's some orphan disease and very little. Like whatever you did, you will never add. So you always have a huge data set of imbalanced classes. So without sensitive data generation or data augmentation, it will be very difficult to create proper solution for this data. Also, sensitive data as well, I believe it plays a very critical role in imbalanced data, especially like when you want to tackle real world scenarios like skin condition analysis. What do you think about that?
I think that's a very valid point that the bias in the data that we worry about can really play a critical role. And the example you gave of this highly heterogeneous data sets, either skin condition or different disease conditions, is an important one. So I take that for sure. Maybe on that note, we can jump into some of the things you're already doing at AlgoFace, Taleb. Can you share a little bit about how you use synthetic data in AlgoFace?
Yeah, in AlgoFace, we focus on developing AI, AR solution related to human face, like face tracking technology, certain facial attributes, or something related to hair as well. Collecting data and labeling the data on, for example, we have 209-point facial landmark tracking system plus other facial attribute detection. Collecting the data and labeling is extremely difficult, tough problem and time consuming. To human in the loop, like when you want to put 100 people to label your data, it is difficult to control the consistency between people who have different opinions on the same image. So recently we start to use sensitive data to augment internally our pool of data. So we have like synthetic faces that we can generate in extremely realistic way. Also we can control the attributes that we are generating to certain degree. So not only you are generating sensitive images to have your data set is more balanced and less privacy concern. Also, in many cases, you can generate 100% perfectly labeled data already. So that's a huge advantage. Like think about if you can generate like people with different skin colors, and if you have controlled model to generate those photos in realistic way, you don't need really to label them. That can really save you months of work and a lot of resources as a startup.
That's great. If I think about the world of renderings, which, as you know, a lot of self-driving car industry uses for its training, versus synthetic data, which, as we just discussed, has still its roots in real data, but using generative models as goes forward. So kind of rendering of scenarios and faces and so on, which are, let's say, purely synthetic, versus data generation. These two techniques today are somewhat distinct. Do you see in your own work these things coming together? Because there are certain physical phenomena that are sufficiently easy to render with purely rendering-based approaches, but may not have data for it, and the other way around. So how do you see these two streams merging at some point?
Yeah, I think I see it coming together already, and I see people even in the market already like trying to marry these two techniques to have more efficient synthetic data generation. When it comes for simulation engines for mostly autonomous car right now, there's big companies using those to simulate certain weather condition or bad road condition that they cannot capture in real world scenarios and train their autonomous driving system on it. When it comes to human face, it is not easy. There's no easy way to generate the synthetic face model, realistic one. You can maybe easily create cartoonish face, but if you want to have some digital artist to create really realistic 3D model on using one of the platform, it takes hours. Like, it is not something easy. But you can merge these two techniques. You can start by generating some libraries of using the 3D artist and create those digital assets and use them and feed them alongside the real data to the generative models to create new 3D or 2D faces together. I think both of them can play nicely together. It's still in its infancy. It's just started, I believe. I think like in the next 3 to 5 years, we will see many platforms of generating, or like for digital artists, they will start to incorporate some generative models technique, embody it, and start to help them to generate and add new features to those faces. And that will pose certain, like maybe concern or question how we are perceiving the human face. I think those, like we will start to maybe look at faces that we don't see in the real world. We don't know how those algorithms explicitly working, and maybe that will affect on our perception of a human face. Like recently, I bought a book, artistic book, about some face recoloring for kids. And what is nice about that book, all those sketches of faces has been created by generative model, by AI. So there's no artist draw those faces, and we are putting these books in the hand of kids, and maybe their perception of human face can be affected slightly.
Fascinating point there about how society might perceive these faces. I mean, Hollywood actors have been worried about, virtual actors replacing them for a very long time. It hasn't happened yet, but maybe you're saying that maybe virtual characters may not happen, but synthetic data generation from some existing lowly paid characters could actually start creating some ripples. What do you think about that, Taleb?
Yeah, I think digital influencer now and digital avatars now, it's becoming really very big thing. Especially in South Asia now, there's a huge industry about digital influencer or digital avatars that they creating totally digital character, full body, face, animation, and even there's some digital YouTubers. Like those characters, they have multi-million follower YouTube channels, some of them targeted toward kids as well. I think this is something really, for me, like from scientific perspective, it is extremely exciting, but also at the same time, it's concerning how those digital character will communicate, what kind of messages and in visual way and audio way on the audience. And like maybe soon we will find maybe YouTube or social media are mixed, like is this real person or this is like digital person? And I don't know if we can say digital. So, and you can find them posting or creating content and even communicating with each other. And when it comes to kids and in education, I think that that can be interesting. Like it can have a lot of advantages and also some concerns to think about it.
Certainly. I mean, when it comes to generative synthetic data, is there something special about human faces compared to other data? Because, kind of evolutionary, we are so tuned to even the most minute changes and any sense of, kind of the chasm of reality. So is there something specific about human faces that you encounter in your work at AlgoFace compared to other synthetic data generation?
Absolutely. Human face is the most captured object in the history from, from even like painting or photography, like billions of faces, like, people like everything about a human and our face represent our identity. Everybody wants to capture their faces and upload it in the era of social media. And even in our brain, there's certain area in our visual cortex about processing faces. So, and we are extremely sensitive. A human is extremely sensitive about anything not very realistic or correct in the human face. Like our brain has been trained to recognize people from their faces and recognize their emotional status, and if they are happy, if they are stressed, like even our facial expression are very, very fundamental communication between people. So people like genuinely care a lot about face. And when you start to generate sensitive faces, the bar is really high. Yeah, for example, if you are generating sensitive, I don't know, like products for shelves detection, for like automation of retail store, or if you are generating certain cars, people or even algorithm can be less sensitive. But since the human faces are, in general, they are similar. Like if you want to look at a human face is one object. Like you can accurately train face detection. Like faces are one object, right? Like all a human face, you can group them as one object. But in the same time, like we can recognize this is Taleb, this is Ramesh, this is Jeffrey. So we pay, as you said, our brain trained to take every subtle facial movement or facial attribute changes, and that will be transferred automatically to any AI solution. For example, if you are generating faces for emotion recognition, you need to be extremely careful about how realistic those emotions that you are generating is, and also for the faces and the face segmentation.
Yeah, absolutely. I think this uncanny valley problem has not been easy for even special effects to overcome. So it's which involves a lot of creative, talented input, and the likelihood that a pure algorithm could do that is definitely an uphill task. So given that, I mean, as you know, there are about a dozen companies that sell so-called generative synthetic data products out there. But I assume at AlgoFace, creating generative synthetic data for faces is still a very unique problem. So what's your own take inside AlgoFace? Do you have your own modules, or are there some modules or products that you think are pretty commonplace now, and then you would encourage our viewers to use?
Yeah. Actually, like, there's very, very few players in this market, like very few, maybe around the globe, to the best of my knowledge, there's less than something around 5 serious companies. They have some serious product in the market now. All of them emerged in the last couple of years. So there's very, very few players. there's some few companies that we are talking with about their ability on generating synthetic, realistic faces. And in the same time, we are working on our own solutions to create synthetic data that satisfy our needs. Because in AlgoFace, we are working on some unique solutions that not very popular. So those service provider, they may not have exactly what we need, and what we need may take a lot of customization on their work. So we are working also internally because we have already big, huge data set, proprietary data set. We know our problems very well. We have very good pool of talented in this area. So mostly like we are creating our own synthetic data internally to this point. And this is still like early stage initiative, and it's still, it needs certain time to mature and be able maybe at one day to replace the need for any real data at all. We can like, maybe the dream is train AI model on 100% synthetic data and test it on 100% real data, and it works perfectly or as good as if you train it on 100% real data.
Yes, that's fascinating. I mean, I still remember the demo video that you and the AlgoFace team had posted about 2 years ago on being able to do facial landmark detection in real time, independent of race, gender, skin color, and so on. And I think that remains one of the leading demos in this space. So I'm looking forward to some amazing innovations in the field of generative synthetic data as well, coming from your team. And then just to kind of wrap up, how do you see it? I mean, one dream you said is, so little data, you said of the order of 100 images, enough to create, other synthetic data. What is the other dream? I mean, if I look at children, they're able to see just a few, snapshots of new people, and start making assumptions based on that, whether it's faces or poses or other visual inputs. If I look at, the progress we have seen in speech, the synthetic generation there has progressed dramatically. Can you share with us how you see this field progressing over the next few years, especially with respect to how you see this inside AlgoFace?
Yeah. In general, I think one of fundamental problem now in AI that need to be solved is the ability to transfer knowledge from one problem or one space to another. Like as our brain, for example, people can recognize a new object if they saw it one time. For example, maybe 6 years old, show him a new game or new tool one time, and they can memorize it and recognize it after 10 years, even they saw it only once in their life. And that's not possible at all. For example, if you build any like object classification AI model now for like 1,000 objects, and they show them one example of 1,001 object or like other new object, that would be forgettable. Like you cannot. So, but I think our brain works in different way. Like we build object recognition ability in general, regardless of the object themselves. Then we can start to add some library to those objects, and you don't need really to have 1,000 or 10,000 examples of the same object in different orientation to be able to memorize it. That if we arrive to this stage of maturity of supervised learning or unsupervised learning, that can solve and reduce and remove a huge need of new data and lively data. Like all these problems that we are trying to solve on data front for synthetic data generation or real data, because inherently all currently available AI models are extremely hungry for data. I think the next breakthrough that can happen is how about developing some AI models that are not really very hungry for a lot of data? That's really $1 billion question. If somebody can crack this problem, that will be amazing. Inside AlgoFace, we are not like multi-billion-dollar research institute. We are like ambitious startup trying to solve some tough problem related to human face. We want to have extremely accurate and inclusive AI-based solution, like analyzing a human face for good, for face tracking, face animation, augmented reality for human face, maybe like tackling some telehealth. Now telehealth is booming after COVID. Digital psychiatry, digital health, digital vital sign detection. I think if we can build real-time solutions that run inside the consumer device, which is inclusive, it can see all faces regardless of their shape or color or skin conditions, that can make very big difference. And this is what we are fighting and trying to crack in AlgoFace.
That's fantastic. I mean, you're absolutely right that generative synthetic data and its transfer learning and generalization is just the beginning, but it's a really exciting space, and it's always joy to talk to you, Taleb. I hope in coming weeks we get to talk more about other aspects of AI, especially as it relates to face AI. Thanks a lot.
Thank you very much, Ramesh.
Yep, and I want to thank both of you guys for a fantastic conversation. I want to thank everybody for tuning into this week's episode. Again, this is AI in the real world. We had Taleb and Ramesh talking today about AI, synthetic data, and all the other interesting things that are going into this evolving technology. Again, our podcast is going to be the ongoing discussions about this emerging and advanced technology from all the experts like Taleb and Ramesh. We're going to be covering topics such as the sciences, the legal aspect of it, and all the ramifications that go along with it. If you have questions, if you have topics you want to hear about, please feel free to reach out to me. Again, my name is Jeffrey Friedman. I can be reached at Jeffrey, Jeffrey, at algoface.ai. We're looking forward to seeing you on future podcasts, and thanks again to both of you. Really appreciated the time today, and hope everybody got a lot out of it.
Thank you very much, Jeffrey.
Thank you.